In this lesson, I'll talk about rotations in a little more detail, color maps with a gradient, and image maps, which are a way to place a picture on an object. Once again, let's copy the camera, the light source, and the sky sphere from the previous lesson. So highlight all of that and copy it. And create a new lesson and paste that. And then let's make sure that it works the way we want it. Oh yes, have to give it a name, lesson 4. And that looks pretty good. Let me move this render window over a little bit. I want to tell you about rotations in a little more detail, and in order to understand that, it would be a good idea to have an x-axis and a y-axis and maybe a z-axis or a whole grid. We're going to simulate those with cylinders, very thin cylinders. For the x-axis, we're going to create a horizontal cylinder. So type cylinder, okay, start, end of cylinder. We'll make it go from, let's say x equals -5, y and z are 0. That's the base point. And go up to +5 in the x direction, 5, 0, 0. And we'll give it a small radius, let's say a radius of 0.3. And we need to give it a color, let's say pigment. Quick way to do that is pigment and just specify the color, gray. And we'll give it an ambience, that's a finish. Ambient, let's say 0.5, not sure what's best there. Let's take a look and see what this is. Okay, that's kind of a thick cylinder for the x-axis. So let's make the radius of that cylinder really small. Let's say 0.03 or 0.04. Let's try 0.04. Okay, that looks pretty good. So there's a cylinder in the x direction, and we need another one for the y-axis, so let's copy that. Copy and paste it down below. And change the base and cap points so they point in the y direction. So make x 0 and y -5 to 5. So x 0 and y -5 to +5. And let's see what that looks like. Okay, there we have it. See, so the x-axis goes from -5 to 5, and so does the y-axis from -5 to 5. Now, we could also put one for the z-axis, but I've already done that, and I set up a grid using the same idea, having a whole bunch of cylinders going horizontally and vertically. If we highlight what we just did and press the delete key to get rid of it, there, all that work and it's undone. I actually wrote a bunch of lines of code, which I stored in a file called grid.inc. So if you put number include quote grid.inc, then I have lines similar to what we just did, but a bunch more of them, and it draws the whole grid. Let's take a look at this. So now I just have the camera, light source, and sky sphere, but I also included the code from this other file. Oops, I didn't delete everything at the end there. All right, let's try it again. And you see, there's my grid, and I extended X much further. Let's move the camera in a little bit. Let's move it into 20 back instead of 50 back. Get a better view of that grid. This white dot in the middle is that Z-axis coming in and out. We can see this better if I change the location. Let's say I move it 5 in the X direction and say 2 in the Y direction. Let's see how this looks. Aha, there you can see this Z-axis coming in and out. See, it starts at -5 here, and then it goes way out. I made it go much further than 5 out. Now, I'm going to put a box in here. Let's put a 1x1 box with the lower left corner at the origin. So let's do box, begin, end box. And let's specify the lower left corner at 0, 0, 0. And the right corner at 1, 1, 1. So that's a 1x1x1 box, a cube. 1, 1, 1. And we need to give it a color and ambience. So pigment, let's make it red. And finish, ambient. We'll use our old ambient 0.4. Let's take a look at this and see how it is. All right, there we go. We see that box. Let's move the camera angle. Let's zoom in on it a little bit more. Or maybe look at the center of this box is at 1/2 unit because it's 1 unit each way. You can see with the grid what's going on. So changing the camera angle. Let's go in a little more, say -10. Instead of looking at 0 on X and Y, let's look at 1/2 on X and Y so we see the center of this. See if that's a better view. Oh yes, there, we can see what's happening with this box. Now the reason I wanted to do this is so I can show you how rotations work. So let's take our box there and rotate it in various different directions. Let's start by rotating it about the x-axis. So let's say I rotate the box 30 degrees about the x-axis. Okay, so it's going to spin around the x-axis. Take a look at this. See what happened? Now it rotated the 30 degrees towards the z-axis. Let's see, how can you describe that? If you use your left hand and point your thumb in the positive direction of the x-axis, this way, then your fingers curl in the positive angle of the rotation. If I change that to -30 degrees, it'll rotate the other way. See that? So the x-axis here is like the axis of rotation. Let's do it with the y-axis. Change the x rotation to 0 and make the y rotation 30 degrees and see what that does. Okay, so the y-axis is the axis that goes up and down, you see, so it's rotating out towards us. Notice the grid here is slicing it a little bit. If I do the y rotation -30 degrees, it will go the other way. So you see it swung it back 30 degrees. And likewise, let's take a look at a rotation about the z-axis. Remember, the z-axis is the axis that goes in and out of the screen. Okay, so it rotates it like that. There's 30 degrees according to the z-axis. Again, if you point your thumb in the positive direction of the z-axis, which is back of the screen, then it shows your fingers curl this way, so it rotates that way. Well, that's what rotations do. Okay, the next thing I want to show you is how you can use color maps with a gradient. Gives you some interesting effects. We already did this with the sky sphere, and maybe I can make it a little more clear in this lesson by doing it on a box. So I took out the rotation, and I'm also going to take out this grid.include. Let me just comment it out in case I want it again later. Now, if you take that sky sphere, we had a pigment which involved a gradient. So let's copy that. And let's use that as the pigment of our box. So delete this pigment that we have there and paste this in. And let's see what happens when we run it. What did I do wrong? Let's see, no matching in the pigment. Oh, I didn't copy everything from the pigment. That's what I did wrong. Okay, let's try again. Aha! So you see the sky sphere goes from white, that was 0, up to blue, which is 1. Let me move the camera back a little, back to -15, and make the box twice as tall. So let's make the y go up to 2 instead of up to 1. Let's see what happens. And you see that pigment repeats itself. So what's happening with these gradients, the color maps, is they fit on a 1 unit tall area. And then if you go beyond that height, it repeats itself. We can make this pigment more interesting by putting another color in there. And the numbers have to range from 0 to 1. So let's put in a color at halfway, color red. And it should transition from white to red to blue. Let's take a look. Cool. Let me change the height of that box back to 1, so we're just looking at a single box. And notice how the pigment just sort of wraps around the whole box. Now, we specified the color map to have a gradient of y. Suppose I change that to a gradient in the x direction. Let's see what that does. See, now it goes x-wise, and notice the blue where it ends just sort of fills the end of the box there. Another thing you can do, let's go back to y. Another thing you can do with this is you can rotate the pigment itself. So before the close of the pigment, let's do a rotate. Let's rotate the pigment by the z-axis, 0, 0. Let's say 20 degrees. Let's see what that does. Aha! Notice the bands repeating somewhat. Now, if I wanted it to go smoothly from one color like white down to blue at the corners, then I would have to do some rescaling. Let me show you exactly what's happening here. Let me change the positions of the red and the blue, and let's take out this rotate. So put blue in the middle and put red at the bottom, just so we see what differences we get. Okay, so now we have red at the top and it fades to blue and then becomes white at the bottom. And let's put back that rotate. We still get these bands here. If I rotate it negative 20 degrees instead of 20 degrees, then I'd get the bands like this. Suppose I wanted it to transition from white at the lower corner to red at the upper corner. The problem is that we have to scale this gradient somewhat. And I can show you what's happening with a couple of diagrams. That gradient can be thought of as a horizontal rectangle there that transitions from white at the bottom, that's the 0 position, to red at the top, which is the 1 position. And the box that we're putting it on, the box is that square in the middle there. Now, when you rotate it, then the rectangle doesn't quite fill the box because the upper corner there needs a repeat of the rectangle, and that's why you're getting that. Actually, that's rotation through the negative angle as far as the z is concerned. If you want to make it fit the box, what you have to do is you've got to scale it, make it a little bit bigger. And I worked out the math for that. The correct formula for a 1x1 box, the correct scaling formula is actually this. Looks a little complicated. It's the cosine of an angle in radians plus the sine of the angle in radians. Now remember, we actually rotated it through an angle of negative 20 degrees, but the a that you use in this formula would be 20. And let's go back to the program and try that out. So what we need to do before we rotate this gradient is we need to make it a little bit bigger. So we're going to put in scale, and the formula that I had was cos parentheses radians parentheses the angle, which is 20, plus, oh, I didn't close the final parenthesis there, plus sin, that stands for sine, radians, same angle, 20. And let's see if this works. Aha! See? So now I've got the left corner as white and the upper right corner as red. And so if you want the gradient to go sideways somehow at a certain angle, then you have to do that scaling part first and then do your rotate. Scaling makes it big enough so it fits on the unit cube. Now, if you don't want it on a unit cube, you want it on a box of a larger dimension, what you would do is make it a unit box like this, and then you would scale it however you want. You could scale it vertically, you could scale it horizontally, or both ways, or whatever. Let me show you how you might do that. Suppose I want to make this box a little bit bigger in the vertical direction. Then you would say scale, that's the y direction, 1 in the x direction, let's say 1.5 in the y direction, and 1 in the z direction. That'll make it a slightly taller box, you see? And since we already put the gradient on it, we're scaling the whole thing, the whole box that includes the gradient. Another thing you can do, instead of using a color map for the pigment, you can use what's called an image map. And that allows you to put a picture on the object. Let me change the scaling of the box back to 111. Like anything, you have to put it on a unit surface, one that extends 1 unit in the x and the y directions. Now, I have a couple of pictures that we could use. Let me show one of them. The image on the right here is a picture I took at the Isotopes baseball park, and the actual dimensions, which I read from my computer of this image, it's a JPEG, are 722 by 1113. Those are pixels. That information I'm going to need when I scale the box. So let me show you how you can put that picture on the box. So in this pigment, we'll take out the gradient and color map stuff. And we're going to put in that image. And the way you do that is you specify what's called an image map. Image map. You could always look up the syntax of this in the help menu, but I'm copying it over from what I did on paper here. Let's see. Image map, and then set brackets, and you specify the file. It's a JPEG file. They spell it JPEG. And I called it isotope 1.jpg. And I think that was a capital JPG. I don't know if that makes a difference. We'll find out in a moment. And close the image map there. Let me move this over so it makes more sense. And let's see what this does. Aha! There it is. Notice it's kind of squatty. Now here's where that size information comes in handy. What we want to do is we want to scale the box in the X direction, the first number of that image, which was, I forget what it was. Let me look that up. Oh yes, that's 722 by 1113. And let's think about it. We've got the X is 722 wide, and the Y is very tall. Let's see, the Z should be the same as the X. Now that's a really huge box. We'd have to move the camera way back. I don't want to make it that big. So what I can do is divide all these numbers by something. Let's say I divide by 1,000. The middle number is a little bigger than 1,000. Then I'll have the correct proportions for it. And there you go. Now it's the exact same proportions as the picture has. And notice that it continues around what was happening on the left side. That's how you put a picture on it. I could also scale it once again. Let's say I want to make the box a little bit bigger, like 1.5, 1.5 times as big as that. I could do another scale on it, and I get a bigger box. And that's the essence of putting pictures on your objects. In the next lesson, we're going to do that with cylinders and maybe a sphere.